Hi everybody, welcome to Unit 7 review, cones, cylinders, and spheres. And so I hope you have your notebook. If not, go pause this video and go grab it and take notes. That way you can be successful on your test. As always, I've modeled each of these problems kind of like either about information that you need in order to answer it, or I set up a problem just like what you're going to see on the test itself. Okay, so yeah, let's get right into it. So for number one, I'm not going to tell you which ones of these, I don't know if that's the right way to say it even. I'm not going to tell you which of these words that you're going to need, but you are going to need some of them. Okay, so diameter, right? Let's talk about, I'm going to draw a picture and I'm going to kind of talk through what each of these terms is. So for a diameter, that is the length of from one side of the circle, one side of the circle to the other, and it goes through the center of the circle. Okay, it's also the longest chord. Okay, if you know your definitions about different vocabulary words associated with circles, but anyway, it's a line that cuts the circle in half. Okay, and then radius is half of the diameter, right? And it goes from the center to the outside of a circle. Okay, it's that distance. And being that circles from the center, it's equidistant all the way around, no matter where you pull the radius from. If it's a true circle, it should always be the same. So height. Height is it's a perpendicular measurement from the base of whatever you're working with to the opposite vertice. Okay, so like in a cylinder, right? That would be like this length from the top to the bottom. So like the top base to the bottom base. Okay, in a cone, that would be this distance right here from the center to the opposite vertice. This is the vertice. Okay, it's also known as the apex of the cone. For a sphere, it would just be the diameter, right? This goes from one side to the other, but we usually don't refer to that as the height of a sphere. Slant height refers to a cone. That refers to a cone. So if I draw a cone like this, and that's this distance. Okay, like how long that distance is. And usually it's signified with an L, I believe. Okay. An edge, that would be like where two faces meet. So like in a cylinder like this, that would be like right here. That would be the edge. Okay? And then a vertex, that's where two edges meet. Okay? Which on the next page we'll talk about the different amounts of vertices, but like this right here would be a vertice. Or even if I had, now we're not talking about prisms in this unit, we'll talk about that in the next unit, but like this right here, that would be a vertice, right? Another word for corners, all right? So all of that information should help you figure out number one. Number two, you need to know, and you're going to be placing words into the definition of a volume of a cone, okay? So for the volume of a cone, you have pi times the radius squared times the height divided by 3, okay? And then for the volume of a sphere, with this one, for number 3, you're actually going to be solving it. So I'm going to do an example problem with this formula here. So for the volume, we have 4/3 times pi, which we'll use 3.14 as pi, times the radius cubed. Okay, so you got to be careful with that. That's like 2 times 2 times 2. So let me rewrite that out. So we've got 4/3 times pi, which we're going to use 3.14, And then 2 times 2 is 4. And then times 2 again is 8. So this would be times 8. Okay? Now, and I'm going to rearrange this actually to be 4/3 and then times 8 over 1. Okay? Times 3.14. And the reason why I'm doing that is because I could do 4 times 8, and I'm gonna keep going over here. I should have started elsewhere, but that could be like 32 over 3 times 3.14 over 1. And so from that, then I can use my calculator, a handy dandy calculator. Oops, and I'm getting notifications. So I could do 32 times 3.14 and then divide it by 3, right? So I multiplied these together to get me 100.48, and then 3 times 1 is 3. And remember, this is a division problem, right? So we can divide by 3, and that gives us an, let me look on your test. Oh, you're writing out these steps on your test, so you can decide what you're rounding to. Okay, so I could say that this is about 33.49, and since it's volume, it would be units cubed. Okay, so on your test, this is a short answer question. You're going to be either showing, which that's what I would prefer. I'd prefer that you show me your steps, or you're at the very least explaining your steps. Okay, so that's number 3. This next one helps with number 4 and with number 6. Okay, so this, and maybe take a screenshot of this if you want, or write it in your notebook. So for these different shapes, I wrote out the different faces, edges, and vertices. So for a cylinder, it has 3 faces, which if you think about it, that would be like the top, the bottom, and the side, right? Like if you think about a can, right? That'd be like where the label is. Edges, it has 2, so this is a cylinder, right? Here's one edge, here's a second edge, so 2 edges, and 0 vertices, okay? The edges do not meet, so it doesn't have any vertices. And for a cone, it has 2 faces, 1 edge, and 1 vertice, and then spheres have none. All right, that's one reason why they are very unique. Okay, so that was for number 4 and number 6. For number 5, you're finding the volume of a cylinder. So here's your equation. The volume is equal to pi times the radius squared times the height, and now I can't remember. You're filling in the blank. Okay, and we're going to go to the 10th place. So we're going to use 3.14 for pi. Okay. My radius, for this one, it's listed up here. Okay, it's 6 centimeters, or I'm sorry, 6 meters, excuse me. And that's being squared, and then we have it multiplied by the height. That's this length here. Remember, it's from the top of the shape, it's a perpendicular distance down to the base. And in this case, that's 15. So first we will apply our exponent. So 6 squared, that's 6 times 6, or 36. And then times 15. I'm going to pull out my calculator. So I've got 3.14 times 36 times 15. That gives me 1,695 and 6/10 meters. And since we're talking about volume, that will be a cubed unit. Okay, that's a 3-dimensional attribute. Just 3 more, and then we're done. There's only 9 questions on this test. That's not bad. For number 7, A water tank is a cylinder with a radius of 7 meters and a height of 10 meters. How much water can it hold? Okay, so it tells us that it is a cylinder, right? That's our shape. So here's our formula for the volume of a cylinder. And which really, and if you remember from our other lessons, it's the area of a circle, pi r squared, multiplied by the height, just how many circles are stacked on top of each other. So we'll use, and again, I better check though. We're going to leave this one in terms of pi, all right? So that's a good habit to be in as well. So pi is just going to stay as pi. But then the radius, we can plug in 7 meters. So pi times 7 squared. And a height of 10. So multiplied by 10. So in this particular case, we'd have pi, then 7 squared is equal to 49 times 10. So that would be pi times 490 in this particular case. And we could leave it like that, but when you leave it in terms of pi, pi almost acts like a variable. And so it actually gets put after the number itself. So in this particular case, we'd have 490 pi meters cubed, right? Which is technically more of an exact answer than if we were to use 3.14, because we listed pi. And that's how we write it without being able to write out the entire thing, which is impossible. Number 8, if a cone and a cylinder, oh yeah, this one, like, just take this information and use it for the problem, okay? Take this information and use it for the problem. If a cone and a cylinder have the same height and it is the same length as the diameter of the bases, the cone is 1/3 the volume of the cylinder, okay? So the cone is 1/3 the volume of the cylinder. We could also write that the opposite way. We could say the cylinder's volume is 3 times that of the cone. So both those statements are true. They're just written in two opposite ways. Okay, one has the cone first, the other has the cylinder first. So just take that information and use it to answer the question. Okay? And then number 9, you're going to need to check off the correct 3 answers. So keep that in mind. There are 3 correct answers. And I want you to think about the difference between surface area and volume. Right? Surface area would be like if you were to wrap something in paper, right? Think about like a gift box or something like that. How much paper do you need? Volume is how much something can fill or like fit in it. Okay? So think about those differences while you are answering number 9. Okay? But I hope it goes well, and if you need support after you take it, if it doesn't, just let me know. Okay?